Raymond Wolfgang here with a systems engineering tip that's going to help your systems engineering career, help you separate from the pack, and give you the mindset where you're going to make the right decisions real time. Now, today's topic is going to be to discuss systems engineering versus systems architecting versus systems thinking. Now, there's a previous post on this. This is to clarify some of those issues. But systems engineering, very briefly, is the process that I use to develop solid products. Okay, systems thinking is a mindset where we're always asking ourselves, what else does our product touch? Who do we need to interface with? Is the solution we're looking for really technical? Maybe there's some clever non-technical solution there. And the system architecting, I used to have that as a third peer, but that really follows from doing the systems engineering with a systems thinking mindset. Okay, now hold tight. We'll discuss all this in a little more detail. And this is inspired by Dr. David Snowden's keynote at the recent INCOSE International Symposium. It was in Dublin, Ireland, a spectacular event. DM me if you want more details there. But David Snowden does the Cynefin framework, and I do recommend taking a look at that. That'll help introduce systems thinking as well as some complexity thinking, which helps you manage projects in a way where you have the right tool for the right job. Okay, now for systems thinking, again, that's more of a mindset. We're asking, okay, if we're solving a problem, is there a system solution? Because most problems I found are more systemic. Case in point, Cape Town, South Africa, a couple years ago, really had very low reservoir levels. They were running out of water, drinking water. So they went through a very large campaign to get people to change their habits, use less water, but also to fix what are called micro leaks. So think of a dripping faucet. Okay, well, dripping faucet times 100,000 people, that's a lot of water. But they approached it in a systems fashion. Namely, they said, okay, our problem is we're using too much water. Is it just a technical solution? Well, yeah, we need to identify cracks, and they use technology and engineering to do that. But also was a cultural behavioral issue that they needed to address. So that's a great example of a systems solution for a pretty critical problem. Now, the systems engineering would come in where we say, okay, we want to fix these micro cracks, or there are requirements. Okay, how do we do this? And then we bring in technology, some sensing, and then maybe there's some advanced ways to, plug cracks, which there are ways to do that. That would come up with the engineering solution. System engineering, of course, is like the IEEE 15288 process, where, again, we have needs, decanting to requirements. We then start our architecting, our system architecting, go into a verification regime, which technically we do all along the process, and then we have final validation. Okay, so the systems engineering is more an engineering process and art to manage a technical project, the technical part of a technical project, to get the right system out at the end of the time and the money. So again, we're in the real world here. We need to finish on time and to scope as well as to cost. Okay, so we've covered systems thinking, systems engineering, okay, again, the mindset and the process. Where system architecting comes in is, again, we're developing needs of the customer, okay? We're thinking systemically, and we're starting to have ideas. Okay, well, the system could have a cultural piece over here, and then a technical piece, let's say, for using less water. And as we talk to the customer, as engineers, we're going to come up with architecture ideas. So those we capture, and then when we get more into the systems engineering process, we're going to use that architecture to allocate requirements, maybe get a functional architecture, get requirements off of that, go back and forth in this dance between, our candidate design and requirements development. And so eventually we're going to get things that we're going to have the engineers build, okay, low-level requirements on a physical architecture, and then we'll have an integration strategy to put it all together. So those are three biggies. You have systems thinking, which you need to do systems engineering well. That's the second piece. And then the system architecting, that's more as we go along. If you had to pick two of the three as major pillars, I do systems thinking, system engineering. The architecting will come. But again, it's part of the creative part of being an engineer. Okay, we have this architecture that is informed by our systemic thinking and then is developed through our systems engineering process. So all three of them work together. This tip is going to help you on your workplace when if you're facing a task or you're trying to architect a system, you can bring in these pieces to help get a great architecture early on in your project, and then really be on solid footing when you're starting to develop test plans and requirements, and you're doing low-level costing and scheduling. So you're doing a little of this up front is just going to get you a great system in the end, and it's going to save you a lot of headaches when you're doing the hardcore, low-level system engineering downstream. So comment below what you think. You can direct message me. If you comment below, hashtag systems thinking, I'll get you some resources there that you'll want to read, you want to check out. And also DM me if you want some ideas on some past INCOSE keynotes, which speak to some of this. And let's engage in comments. So I look forward to your comment, and I'll see you in the next tip.